Let's look at mean value theorem of integrals visually. So let's go to geogebra.org and start calculator. Okay. Now here we require an interval. So let us say A and B. And let's make this from -3 to 1. We need a function. So f of x is equal to minus 2x minus, okay, and we want the interval. So let's say function with values start and end. So function is f, start x value is let's say a, and end x value is b. So here there is one line and one line segment. So if I remove this, this is your f of x, and this is that f of x restricted to this particular interval. Now what we want is the area under the curve. So let's say integral from a to b. Yes, so let's zoom in and see how it looks like. Okay, so we have this area, and the total area is 0 because positive area and the negative area are equal, so they cancel out. Okay, now what we have to figure out is the mean value of the function. Now here, since the total area is 0, that means the mean value should also be 0. Okay, so let's see. So how do we figure out that? If we remember the formula, 1 by b minus a times the integral of f from a to b, which we have already evaluated at as c. That gives us 0. We need to figure out the value of x for which d is. So we need to do some solving. So solutions f, when f is equal to d, right, this d value we have got, for what value of x is d, or the f of x is 0, so that is -1. So at -1 it is 0, and now let's define it as a point L1, the first solution. There is only one solution, but generally speaking is the first solution, and f of L1 of 1. So this is the point through which, if we draw a line parallel to the x-axis, we get an area which is equal to the area under the curve. When I change the function, you will see what I mean by that. So now we need to create a line. So y is equal to d, so in red. So the area under the curve is 0. So to figure out that, we do one more integral. Integral of h from a to b. So the area is 0. Both area under this red line, it is 0. And here also the area is 0. Now, if I change the function, it will become much more clearer. So let us say x square, right? Now you see the areas are still same. Now let me just change the colors of this so that it becomes much more clearer. So let's change the color to say red. And now what I'll do is I will remove this. So this is the area under the curve, -2x square minus 2, between -3 and 1. This is the area under the curve. Now we have found a point on the curve where if we draw a line parallel to the x-axis, will give us the same area rectangle, a rectangle with the same area as this. So let's make it visible and let's hide this function. So you see this rectangle has the same area as the area under the curve. In other words, this this part of the area, this part of the area is going to be equal to this part of the area because the total areas are same. So that is what this mean value theorem means visually. And you can keep changing this function to figure out in case of different contexts. Let's say natural log of x, right? And let's say we want it from 2 to 4, or let's say 2 to 6. So which means we have to change this to 6, no, 2 to 6. So if you notice, the area under the rectangle area is equal to the area under the curve. Since there is a common area, the areas which are disjoint are going to be equal. So this area and this area is going to be equal. Okay. You know, the fun part of this is that you can keep changing this. You can try out this with different functions. And second is you can change this to see how the area changes, right? Or the mean value changes as you change the interval. And at every point, you will notice that the area is going to be equal. So here the common area is this rectangle less this part and this part. Yes, this part and this part is not common. This part and this part is not common. So that means this area, this part and this small part, add it up. This will be equal to the area here and here. So that is mean value theorem. That's it. Bye.